Okay, I'm recording. Shh, don't tell anyone. Hi, Diamond. Hi, Mikhail. Keep your cameras on. Let's have a party. I have some coffee. I don't know what you guys have. Somebody, I think Cassidy was making coffee. I can see. Cassidy, that's a nice kitchen or that's a nice house. Looks. I like the color of your cupboards, like the cabinets. They're very dark, rich. Whatever. What color is that? Like brown? Not brown.
Walnut or
Walnut, yeah. We had that when we entered our house 12 years ago. Now it's fading. All right, let's go to the board. What am I supposed to do? Am I supposed to I'm supposed to switch the camera. Okay. Uh-oh. It is not HD. Hold on just a second. Let me just set it up. HD. Do not mirror my board. Okay. All right. There you go. Let's see how much you have retained. Let's do some simple electronic configurations. These are going to be easy points to grab in the final. The final is supposed to be 2 hours. I will make it's going to be very much like an exam. Okay, nothing funny, nothing weird, nothing different. Same style, same level of questions, multiple choice. Instead of 30 questions, maybe there will be 60 questions. I don't know. Maybe not 60 questions. Maybe, I don't know, maybe 40, 50 questions. Bunch of questions will be bonus. Okay, so you're supposed to answer. Let's say if I give you, I'm just giving you an example. If I give you 30 questions, you're supposed to answer 25. And the extra 5 will be bonus questions. Okay, how much each bonus question will carry, I'll figure it out. Okay. And again, don't look at Canvas. Don't look at Canvas and freak out that, oh my God, I'm failing because look at my situation. It's all going to be normalized and added and adjusted. So let's erase the board.
is there going to be like bonus points no matter how many questions are asked on the final then?
What, Cassidy? I couldn't hear. Sorry, my volume was too low. I'm just
Are there going
making.
to be bonus points regardless of how many questions are on it then? Like if there's like 60 or 50, you're still going to make the last 5 bonus.
If there are 1,000 questions, there will maybe 100 questions will be bonus. How about that? Does it make your morning? I'm just kidding. Yeah, yeah, yeah. There will be bonus questions irrespective of how many total questions are there. Yeah. So I always like to do it this way. Like when you do the free response exam, like in the old days before pandemic happened, it seems like pandemic has been going on for like 10 years. Before the pandemic, I used to write a special bonus question for usually 128A and B. And I never did this multiple choice questions for Chem 8. Maybe I did it for one semester for in-person classes. But now it's better to just have so many questions and this many of those many are bonus. I think that's easier. And the Canvas multiple choice questions, they work out pretty good. It's almost like a Scantron, and the interesting thing is it takes me time to write the exam, but grading is automatic, right? So it's saves me some time. All my time goes for the organic lab to keep everyone happy there. All right, let's go back to the beginning of the universe. Okay, so as I said, no lecturing today. Just you have to kind of work it out. And those of you who missed it, I'll just mention it one more time, like how we are going to do it. Let's warm up, okay? Let's warm up with some simple stuff. All right, let's electronic configuration of electronic configuration of number one. Start working on it. Lithium.
The board is blurry.
That's okay. It's too early for the camera to work function properly. All right. Electronic configuration of lithium. So work it out. You can do it two ways. You can work it out and write something on a piece of paper and hold it in front of the camera. You can show it that way, or you can dictate me. You can just say, when I'm done, just say, Dr. Maitra or Shantanu, lithium is going to be blah, blah, blah. Okay. All right. So lithium, how about beryllium? How about, let's do a bunch of them. Let's warm up. Let's do carbon. Let's do nitrogen. Let's do oxygen. Let's do fluorine. Yeah. How about boron? How about, yeah, that should be good. Just this is just for practice. Anybody wants to dictate? Tell me like what to write across one of these elements, or you can work it out. Otherwise, I'm going to sit down and fall asleep. I sat down. I haven't fallen asleep yet.
Lithium is 1s2.
Hold on. This is who?
Soad.
Hi, good morning. How are you?
Good morning.
Which one are you working on?
Lithium.
Lithium. Okay, lithium is 1s2.
2s1.
That's it? It's that simple?
Yes.
Sounds good. Anybody else? You're keeping me busy.
Carbon is 1s2, 2s2, 2p2.
Great. Anybody else? I better not sit down.
Beryllium is 1s2.
Which one? Beryllium?
Yes, 1s2, 2s2.
Sounds good to me. Please participate. Look, the reason I put carbon, nitrogen, oxygen, fluorine, there is a reason. It's you just add one more, right? So those of you who are a little worried about making a mistake, try one of these guys.
Nitrogen is 1s2, 2s2, 2p3.
Perfect.
Oxygen is 1s2, 2s2, 2p4.
Very nice. I'm enjoying already. And the coffee is helping, even though it's
boron is 1s2.
Which one?
2s2. Boron.
1s2.
2s2. 2p1.
Fluorine. Who wants to be the fluorinator?
1s2, 2s2, 2p5.
Fantastic. with this, I'm not kidding. I'm not trying to trick you. I'm just trying to see like what else can we, how can we maximize our practice with what we have right now? What about doing this? I have an idea. What about drawing their Lewis dot structures as well? Okay, that'll be hard. Well, that's you can still dictate me. So pick an element, for example, carbon, then ask me to write a big C, and then ask me to write dots around it. Like you can use north, south, west, and east. You say, Shantanu, you put one dot on the top, one to the right, one at the bottom, two on the left, something like that. Anybody wants to try that? So now let's work on, so we did this. This is great, fantastic. All of them are correct. They're perfect. So now let's do Lewis dot structure. Okay, anybody wants to dictate me, help me write it? Any of the elements? How do we do Lewis dot structure of elements?
So
Pick an element first.
carbon,
Carbon, very good. So what shall I write? P or G or X?
a C.
I'm just messing with you. Okay. How many
Four
words?
points.
Sorry?
Four dots.
Where? All of them here on the top?
No, one on the top, one on the bottom, one on the side, left and right.
Left to right we go. Ho, 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 ho. See, I'm in a very good mood right now. You should be taking your final exam right now. That sounds good. Something else, somebody else?
Nitrogen.
Oh, go ahead.
Nitrogen, Vincent. What shall I write? What's the...
It's the same as carbon. Oh, capital N. Except you put 2 dots on the top instead of 1.
What's that called? The 2 eyes?
Lone pairs.
Lone pair. Lonely pair. Come to my house. Okay, what else?
Fluorine.
Fluorine.
A lone pair on top, a lone pair on the right, a lone pair on the left, and then one on the bottom.
Oh my God. So messy. Let's finish them all. Come on. Anybody else? Any other element? I like it. I like the way our review is going today. Really, I'm loving it.
Lithium is just one dot.
Which one? Lithium is just one dot? What? Okay. Like One Direction, one dot. That could be the name of a musical group. One dot. That doesn't sound musical at all. One dot sounds like a really messed up musical group.
Oxygen has a lone pair on top, a lone pair to the left, and then one dot on the right and one dot on the bottom.
One dot on the left, one dot on the top. Looks good. Boron. Anybody else? Boron and beryllium? Come on, you can do it.
Beryllium has one dot on the top and then one dot to the right.
Yeah, something like that. Yeah. Okay. Sounds good. Perfect. One more. One more element.
Boron only has 3.
Only 3? Oh. All right. Now let me ask you a question. I'm going to pick a random element. How about oxygen? What is its atomic number? Don't look at the periodic table if you have one in within your vision, wherever your vision goes. What's the atomic number? Calculate it from its electronic configuration.
6.
Vincent, the monsters are coming toward your.
Get it wrong.
6 is wrong.
Oh no.
8.
8. I take it back.
Don't do that. Let's pick another element. Beryllium. How many kinds of orbitals are there? Just one type of orbital? I mean, sorry, I didn't want to say that. How many different shells are there? And what are they called? They're named. Like one shell is close to the nucleus and other shells are outside. There are two different words. One is
Valence
word, huh?
no. Valence shell.
Valence
And-
shell, VALENCE,
And
and
the core shell.
core shell. Okay. For beryllium, how many electrons are in core shell? Give me the number, somebody in the audience. How
2.
many electrons in the core shell of beryllium?
2.
How many electrons in the valence shell?
3.
2. Okay.
2.
Yeah, sounds good. So for the Lewis dot structure, which electrons are you actually showing on the Lewis dot structure? Core or valence or both?
The valence
Valence.
electrons.
Valence.
There is a coyote. I'm not kidding. I think he's trying to get into our school. Maybe he will be a chemist. I just saw a coyote. How lucky I am. Okay, so Lewis dot structures are only valence shells. So if you look at a Lewis dot structure, and if I say, this will be a good trick question. If I show you that and ask you, this could be really misleading. Don't screw up, okay? If I show you that oxygen's Lewis dot structure and ask you to write the atomic number, I'm going to block the board if I could. I need it to be a really bigger than who I am. The atomic number is it's very easy to make a mistake, right? What Vincent almost did. What's the atomic number for oxygen?
8.
8.
There are two more which we are not showing, right?
The core one.
It's a 4.
4, yeah, not 6. So keep that in mind. What else can we talk about here? Valence shell, core shell. One of these elements, we talked about ground state and excited state before it bonds with other elements. Which element are we talking about? Between lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. One of them is in its ground state right now. Before it, say, makes bonds with hydrogens, it bumps one electron to a different orbital. Which one are we talking? Sorry?
Carbon.
Carbon, yes. So this is its ground state. Okay. In the excited state, do you remember, can somebody just orally like state like what happens? Which one jumps to where?
It jumps from the 2s to the 2p.
So that it has all 4 unpaired electrons. Okay, very good. Okay, I think it looks good. I'm not going to take pictures. I'm being a little lazy today. I think I have the right to be a little lazy. I'm not going to take pictures. I'm just going to upload the video. Okay, it's going to be a long video. Any questions regarding here? You can always ask me questions. I like the way you guys are participating today. Any questions? You're good so far? I am recording, so if your friends were not being able to come here, they will get to see what we did in the review. You're good, right? You guys are comfortable? Okay. Looks like silence means wisdom. Confucius says a silent man is probably a wise man. So that doesn't apply to me. Okay, so Lewis dot structures help us figure out the chemical composition of a molecule, right? So if this is carbon, you guys already did it. If this is carbon, this is nitrogen, this is oxygen, and this is fluorine. Okay, and this is hydrogen. And this is hydrogen. Right? Lewis dot structures. What should be the formula of chemical formula of a molecule with carbon and hydrogen, nitrogen and hydrogen, oxygen and hydrogen, fluorine and hydrogen? Tell me. So what I'm trying to ask you is, what's the valence? Like, how many hands do I have? How many hands does each element have? So how many carbons and how many hydrogens? How many nitrogens and how many hydrogens? Oxygen and hydrogen, fluorine and hydrogen. So let's go with carbon and hydrogen. What should be the formula? How many carbons and how many hydrogens minimum can make a decent organic compound?
4 hydrogens on the carbon.
How many hydrogens?
4 hydrogens on the carbon.
How about N and H?
3 hydrogens.
Somebody else, oxygen and hydrogen. I just want everyone to participate.
2 hydrogens, 1 oxygen.
Oh no. Fluorine and hydrogen.
1 hydrogen per fluorine.
So FH, so usually we write HF.
H.
So if I now ask you to draw the Lewis dot structure, let's just practice one. Let's practice the Lewis dot structure of water. Help me. So Lewis dot of that. How do we do it? So help. What shall I draw first?
The oxygen.
Oxygen.
And
So
then
let's do this. Okay, then what?
connect 1 hydrogen per
Single electron,
dot.
right?
Yeah.
Sounds good. So you know how to do that. Now with your added knowledge, let's add one more element, and then I will talk about something slightly different. Boron is this, right? So boron and hydrogen, what should be the formula?
BH3.
BH3. Let's draw the Lewis dot structure of BH3. If you look at BH3 and NH3, Think before you answer. Think, I'll give you like whole 2 minutes. These two guys. Okay. Think before you answer. File means loving, okay? I'm going to write down 2 words, and I'll try to make sure that I'm not helping you with color coding. One word is nucleophile, and the other word is explain what nucleophile means. One of you. What does nucleophile mean? Phile means loving. Electrophile, phile means loving. That means
Nucleus
what kind of properties do they have?
Is it nucleus loving, the nucleophile?
Nucleus loving is nucleophile. That means what kind of charge loving? What is special about nucleophile? What does it have that the electrophile doesn't have? Nucleus loving means positive loving, right? So it must have something that it has what?
Positive charge.
It is. So nucleophile basically means positive charge loving. Why would positive charge go to a nucleophile? What does nucleophile have that
Negative
can make,
charge.
sorry?
A negative charge.
Negative charge or what? What can help a positive charge?
A lone pair.
Lone pair, right? Electrophile means what?
Electron loving.
Electron loving. Electron loving species are themselves what? They're short of electrons. That means they're short of electron means they have more protons.
They're positive.
They're either positive or there is something screwed up about their structure. They're missing electrons. Okay. Now with that, I want you to label BH3 and NH3, one as a nucleophile and one as an electrophile. How would you go about it? Which one is which?
BH3 is the electrophile because it's neutral or positive, maybe.
It's not positive.
Well, neutral is it? It doesn't have a lone pair like NH3.
It doesn't have anything here. This is empty. It was basically, I'm not going to say that word and get into trouble. I can come up with a different word. You know, sometimes you're stuck with one word that's very inappropriate to speak in front of a child, but you can think of anything else. It's one of those moments. You know, it's got some problem, some defect. What's ammonia? Nucleophile or electrophile?
File.
You don't have to think so much. Come on, we talked about it so much in the nucleophilic substitution and nucleophilic acyl something reaction.
It's the nucleophile.
It's nucleophile.
Thank you, Diamond. It's a nucleophile. If I sit for like 5 days, maybe I can come up with a song. It's a nucleophile. Okay, sounds good. See, I mean, I might throw one question in the final exam that's going to be kind of hard. That's part of the bonus, right? 5 questions can be hard. Not necessarily, so don't get too worried. So if you see BH3 with an empty orbital and NH3 with a lone pair, they can actually react together. They can form like a little molecule. Okay, so keep that in mind. What else can I ask you about here? Okay, let's talk about it. I'm not going to delve too deep. Okay, I'm going to kind of talk about it on the surface. When CH4 is made, right? When CH4 is made, you remember that the carbon goes from ground state to electronic excited state, right? So carbon is, this is how carbon is born. We already talked about it. 1s2, 2s2, 2p2, right? This is how it's born. But before carbon can have 4 anchors or 4 unpaired electrons, this is the ground state. It needs to do something. It needs to go to the excited state. And you already answered that one of the electrons jumps to the p orbital. Now it has 4 unpaired electrons. It's in pretty good shape. But we have discussed that something else happens to the carbon before it can make 4 identical energy orbitals. What's that process called?
Hybridization.
Hybridization. Basically mixing of orbitals, right? And in methane, this molecule, what's the hybridization of carbon? sp3, sp2, sp.
sp3.
So 4 identical orbitals. Okay. So when methane happens, all the 4 bonds are of same length. Okay. This guy in the center is sp3. sp3 hybridized. Okay, we have settled on that. What's the shape of the molecule? Who remembers? Somebody who has not answered today. Can you guys take some little initiative and try to answer? What's the shape of the methane molecule? It's a T word.
Tetrahedral.
Sorry?
Tetrahedral.
Tetrahedral. Tetrahedral. Sounds very deep and important. Tetrahedral. Excellent. So if we have to show them in, this is 2D representation, you should know how to do the 3D representation like this. This is the true representation of methane. What are the bond angles like?
(109.5).
Yes. That looks good. Yeah. So I think we have covered quite a bit. Hybridization. Let's practice hybridization a little bit more. Okay. Any questions so far? Good so far? By the way, this is also sp3. This is also sp3. This is also sp3. Those tetrahedrals are not really good tetrahedral. We used a word, an adjective before tetrahedral. What was that word? Do you remember? It's a D word.
Distorted.
Distorted, yeah. Distorted tetrahedral because it's not perfect. If I ask you the shape of water molecule, You can say distorted tetrahedral, that's fine. What could be another word for that?
Bent.
Bent. Bent or V or something. Okay. All right. I think I'm running out of ideas to ask from here. Looks good. Okay. Let's erase and let's keep going. So far, so good. I like the way the review is going. This is excellent. Very good participation. Okay, so now what I'm gonna do is I'm gonna draw a big molecule and point at different body parts and ask you questions like, what's the hybridization? What's the bond angle? Blah, blah, blah. Okay, let's draw a compound. Okay. I'll help you with numbering it. It'll be easier for me to ask you questions this way. Okay. Ready? Let me do my mental organic chemistry. Mental math. Okay. Ready? What am I going to ask you now? Anybody wants to read my mind? What do you think I'm going to ask? Number of pi bonds.
Three.
Sorry?
Three.
3.
I agree.
You guys agree? Who said Soad or Jana? I couldn't tell.
It was odd.
Okay. 3. Correct? Anybody wants to challenge that answer? Looks good. Thank you. Number of sigma bonds. That's what I was doing before I asked you the question. I thought that somebody might be figuring that out. Like, what am I doing? How many sigma bonds? Do it carefully. If you have to, draw it out with all the hydrogens.
14.
Sorry?
14.
Don't think so, but let me double check. I think that's a wrong answer. You're off by 1. One, two, three, 4, 5, 6, 2 hydrogen, 7, 8, 9, 10, 11, 12, just 1, 13.
Oh, okay.
Am I correct or did I screw up something?
No, yeah, you're right.
Does it look right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. Everybody's okay? Happy? Okay. All right. What else can I ask you? How many carbons, number of sp3 carbon? How many sp3 carbons number of sp3 carbons, number of sp2 carbon, number of sp carbon. How many sp3 carbons are there?
2.
2.
sp2.
2. And also 2.
Yes. Good job. All right. What else can I ask you? Let me see if you can do it. Assuming that this is a pi bond. I'm just telling you that this is a pi bond. What's the makeup of that pi bond? What is it made from? What kind of orbital electrons? What is this guy made out of? Think before you answer. Take half a minute if you need to. Otherwise, answer.
Ladder overlap? Is that what you're asking?
No, I'm asking you, is it made from one sp3 orbital electron and another sp3 orbital electron? Is it made from an sp3 and an 1s? What kind of orbitals electrons are coming from?
SP and SP.
Think. Pi bond is different. Pi bonds are actually easier to answer. Anybody?
2PZ.
Yeah, let's say 2p. 2p and what?
2P.
2p and 2p. 2p or not 2p. Okay. What about this pi bond? What is that pi bond made out of? I'm just dramatizing it for confusing you deliberately. What is that pi bond made out of? Something different? Ooh. Sounding like Yoda. Ooh. Come on, man. Don't think so much. Just answer. Just do it. I'm trying to trick you by making things so. Sorry?
2P.
It's the same. 2P, 2P.
2p and 2p. In my mother tongue, Bengali, 2p means cat. Okay. Okay, sounds good. Let's keep checking because you guys stumbled a little bit. What is this bond made from? What kind of orbitals? That carbon and this hydrogen. Think before you answer. Think. You need to think a little bit. Think what kind of hybridization is there and then go from there. What is that CH bond made from?
SP2 and 1s.
Perfect. Chengshi, you nailed it. This carbon and this carbon, this CC bond, what is that made from?
2 sp3 bonds.
Okay, I would rather say, Jana, instead of saying 2 sp3 bonds, that's perfect answer, but don't get confused. So I would say sp3, sp3. Perfect. Excellent. I think you guys got it. So that could be some sort of question I might be asking, okay? What else can we ask? I know what to ask. Bond angle. The smiley face. What's the bond angle there?
.5.
5.
What's the bond angle here?
The same.
120.
Hybridization sp2, 120. Do we need to discuss it or you're okay? Around sp2, it's 120. Around sp3, it's 109. Around sp, what's the bond angle here?
180.
180.
Perfect. We haven't talked about it. I'm just curious to see what's your take on it. The carbon 5, carbon 6 bond, carbon 4, carbon 3 bond, and carbon 2, carbon 1 bond. Okay, I'm just curious. I just want to see how you think. Which of the bonds, 5, 6, 3, 4, the single bond, the double bond, and the triple bond, which bond do you think is the shortest? This could be a tough bonus question, and I have not prepared you for that.
The triple bonds are the shortest.
Yep. Perfect. Very good. This could be a bonus question of the bonus questions. What else can we ask? Okay, there is some room here. Okay, so let's talk about what do we do. Let's do some simple nomenclature. That's a bad bond. Name it. Diamond, what's your major? I'm just curious.
Oh, nutrition.
Okay. How far along are you?
I'm in a weird spot. I'm technically in my junior year, but I have some prerequisites to fill.
So what's your career plan?
I want to be a sports dietitian, like for NFL athletes or NBA athletes or something professional league like that.
Sounds very important.
Yeah.
You will probably be owning an island someday.
Oh, hopefully.
Yeah. Okay. Sounds good. All right. Name it. What did the frog say to the princess? Name it. Name me. If you can name me, what? Okay, sorry, I'm distracting you.
To Pantene. No, Pen. Yeah, Pantene.
Pantene, like the shampoo. Pantene. To. What is sword missing? Something is missing. Remember the dance? This is how we dance. These are the dance moves. Does it ring a bell?
Do we have to include the trams?
Check up on those learnings. Watch those videos, make sure you're on top of it. Cis and trans. So the cis version of it will be, how will it look like? This will be the cis version. Big groups, same side, big groups, opposite side. Remember, there is a hydrogen here and there. All right, we still have some room. Let's name an alkane. Name it. If you can name it, if the princess can name the frog properly, the frog will become the prince. He's under some kind of a spell, like curse by a witch. He has to be named properly by the princess. Whichever princess can name him properly, they will be, you know, together for the rest of their life and live happily ever after. That's actually a lie. Happily ever after. It's not true. It's probably true. Okay, name it. Longest chain. 1, 2, 3, 4, 5, 6, 7. Heptane. This is Mr. Tane. His first name is Hep and his last name is Tane.
3-isobutyl heptane.
Oh, John.
It's
Hold on. Let's go. This is a very common mistake, and without any hard feelings. 3-isobutyl heptane. Jonna, I want you to pay more attention to finding the longest chain. Doesn't have to be the horizontal line. Okay, I want you to figure out what you did wrong, because I don't want you to do it next week. I want you to get this in the final if something like this is there. So those of you who think this is correct, this is not the longest chain. Okay, so this is actually wrong. So find the longest chain.
It's octane. It's 8.
Yes, the red line that I overdrew, that's the correct longest chain. Jonna, everybody got it? 1, 2,
Yeah.
3, 4, 5, 6, 7, 8. So don't fall in this trap. There could be a trap like this, and I will consider it as a general normal question. So this is an octane. Okay. If this is an octane, what are the groups attached to it? So if the red line is the main longest chain, this is a group. This is a group. So now figure out how should you name it. Now you can work on it again. Just give everyone like a minute before if you have the answer ready, just hold off. Let's wait for 1 minute so that everybody can work on it. So octane, something octane, and you need to number the chain the correct direction. Anyone? How should we number, from left to down or down to left?
Down to left.
down to left.
So it should be 1, 2, 3, 4, 5, 6, 7, 8. Okay, now it's fairly easy. So finish the job.
4-ethyl 2-methyl octane.
4-ethyl hyphen 2-methyl. Yep. Sounds good. So we still have some room. What is it called? It's a compound. I'm not drawing a triangle. It's not a geometry class. I love geometry, but then unfortunately we have to be serious now. What is it?
Cyclopropane.
Cyclopropane. cyclopropane and cyclobutane, cyclopentane, you guys know cyclohexane. Which of the four compounds has the carbon, 6 carbons or 5 carbons or 4 or 3 carbons in the most comfortable situation state? Which one is the happiest of the bunch?
The one on the bottom.
Cyclohexane.
Cyclohexane, right? What's the shape of the triangle? Sorry? You are right. So say
Planner.
planner. Okay. Anybody else planner?
Cyclobutane.
Butane.
Do you remember the shape of this guy?
Envelope.
Envelope. What's the shape of cyclohexane?
Chair.
Chair. Okay, chair has 2 kinds of hydrogens. One is called a word with an E, another one with an A. What are those words?
Equatorial and axial.
Very good. Very good. That's good. Know how the chair looks like, and they can flip. Okay, axial becomes equatorial, equatorial becomes axial. Something important. Remember this molecule, ethane. When you draw them head on, we have this special way of drawing them. Either we draw them this way or we draw them this way, right behind each other, like almost you can't see. Okay. What are those representations called? It's called some special name. It's after somebody's name, whoever figured it out. It's an N word.
Newman
projection.
Newman projection. Which one is which? There's an E word and there's an S word to describe the 2 conformations. The top one, this is called what?
Staggered.
Staggered.
That sounds so German, right? Staggered. This is Professor Staggered. Eclipse. I wanted to answer one question, so I answered eclipse. Okay, I think the board is full. Take a look, scan the board, make sure you're comfortable. Once again, the review is not supposed to be covering everything, and this is not going to be in the final. These questions are not going to be in the final. When I write the final, it's probably going to be happening in the weekend. I'll forget about what we discussed here. So this is just like an overall idea about, going through the different chapters and kind of making sure that you guys understand what's going on. Okay, you can handle this, all that we are talking about. All right, so let's talk about, we didn't talk a lot about alkynes, but you should know what they are. Oh, I forgot. Maybe we should talk about some chemistry of alkenes and alkynes. I'll just quickly mention, okay? So see, I mean, I almost forgot, right? We can't cover everything in 2 hours. Impossible. So if we are not covering the reactions of alkenes, that doesn't mean I will not be asking questions from those sections. So It's fair game. So just don't be too biased about the review. The 2-hour review cannot cover everything. Impossible. This is just to kind of give you a glimpse of the different segments and just to kind of wake you up and like bring you back to the touch of different chapters. But the rest is your job to kind of cover everything. Please study. Ask your employer for cutting you some slack. We did this. Remember, if you react it with HBr, I'm not going to show you the mechanism. The mechanism is important. Okay, it forms. Well, let's quickly show. Either this carbocation happens or this carbocation happens. Okay, these are the intermediates. Okay, because the pi bond picks up the proton. Okay, and then Br minus comes and produces the final deal. Either this guy happens or this guy happens. One or two. Okay. Do you remember what kind of reaction this is? It's first reacting with an H plus. Is H plus an electrophile or a nucleophile? Electron loving, it needs electrons or it needs positive charge. It has a lot of electrons. Electrophile means it needs electrons. Nucleophile means it's got electrons. Which one is it?
Electrophile.
It's an electrophile. So the reaction is, the name of the reaction starts with the word electrophilic. Is this an addition reaction, elimination reaction, or substitution reaction? From this guy to those two guys. Electrophilic, what's the next word? Addition, substitution, or elimination? What does it look like? Are we losing any body part? Are we replacing something with something else? Or we are just adding stuff to it?
Adding.
Thank you. Electrophilic addition reaction of alkenes or alkynes. Very similar. Okay. Which product is major, 1 or 2? And it's called a Russian scientist. It has a name after Russian scientist. It's called something product. It's an M word. Which one is the right product and what is that name? The name of the Russian chemist.
One is a major.
Sorry?
Number 1 is a major.
1 is the major. And what is the name of that process of the selection? It's called Markovnikov. Markovnikov product. Why is 1 the major? What's up with the carbocations? Which carbocation is more stable, left or right?
Does that have to do with the less hydrogen?
Yes.
The one that has a less hydrogen.
It has to do with the less hydrogen. So this has 1 hydrogen. This carbocation has 2 hydrogens on the carbocation center. There is a way to designate those carbocations. It's called primary, secondary, and tertiary carbocation. So it's either methyl or primary or secondary or tertiary carbocation. Which one is this? Primary, secondary, tertiary, or methyl? When it's attached to one hydrogen. And when it's attached to two hydrogens, what is it? Methyl, primary, secondary, tertiary. Who remembers? You need to remember all this stuff. Anybody remembers? Start with this one, it's just easier. When there are two hydrogens attached, what is it? Primary, secondary, tertiary? I'll tell you it's not methyl. Sorry? This is primary. This is secondary. Primary means two hydrogens. Secondary is one hydrogen. Tertiary, no hydrogen. Tertiary is best. Secondary is okay. Primary is horrible. So this is the major product. Okay. Let's practice something else because I'm going to switch to substitution reactions now using these molecules. Let's name this alkyl halide and that alkyl halide. Name the alkyl halides. What are their names? Molecule 1 and molecule 2. That'll be a nice smooth transition into SN1 and SN2 reaction. Name number 2 first. That's easy.
1-bromo propane, I think. There's the 3 carbon.
Yep. 1-bromopropane. Good job, Vincent. What about this guy?
You replaced the one.
Sure.
Yeah, replace the one with 2.
No problem. Yeah. This is 2-bromopropane. Sounds good. Let's bring in something from the lefty righty chapter. Does any of these compounds, does it have any chiral center? Either of the compounds. Let's look at molecule 2, 1-bromopropane. Does it have any chiral center? Yes or no? I'm gonna write them down up here. Okay, one molecule looks like this. That's number 2, and the other molecule looks like this. This is molecule 1. Okay, now look at those bright purple 1-bromopropane and 2-bromopropane. Does 1-bromopropane, the molecule number 2, does it have any chiral center? What does chiral center have? What's the definition of a chiral center? Chiral carbon.
Doesn't it have to be attached to 4 different groups? And then
4 different groups, yes. Any carbon attached to 4 different groups? No chiral center. How about down here? That's not it. That's not it. How about the central carbon? Is that chiral?
No.
No,
Why not?
because the left and right are the same.
2 methyl groups, identical. What about this molecule? Let's name this molecule first. Can you name it? Is it 1-bromo, 1-methylpropane? Sorry? Say it again. Sorry. You were right. I think you are saying the right thing.
2-bromo. Butene.
2-bromo what?
Butene.
Excellent. Does it have any chiral carbon? Carbon 1, carbon 2, carbon 3, or carbon 4?
Carbon 2.
Excellent. We are covering chirality right now. Let's draw these molecules in front of a mirror. What is the stereochemical relationship between the two bromobutanes? They're both 2-bromobutanes. What is the relationship? They're called what? There is an E word in stereochemistry.
Okay.
Anybody wants to take a shot at pronouncing it?
Enantiomer.
And we had them.
Enantiomers. You had trouble pronouncing it, and I had trouble writing it. Enantiomer. Okay. What is the definition of an enantiomer? What property must be existing between me and my mirror image to be enantiomers? They have mirror image, and what else?
But they're not superimposable.
They're not superimposable. That's right. Got it. Mirror image. Non-superimposable. That's the definition of enantiomers. Now, anybody wants to take a shot at figuring out the absolute stereochemistry or geometry, RNS? Let's go with the molecule on the left first. Okay. I'll help you with the groups. This is a group. This is a group, the tiny group. This is a group. And this is a group. Okay. Can you figure out how do you go about it? Help me with the stepwise process. What do you do first?
You number them.
Sorry?
You number them?
You number them or use the extra large, medium, small, and extra small. Who is extra small here?
Hydrogen.
Extra small. Who is large?
Oh,
Who is large? Sorry.
BR.
BR. Medium and small. So this is R or S on the left.
by putting it in the sun.
So therefore, you don't have to go through it. It has to be R. So this is called absolute geometry or stereochemistry. Keep that in mind. Okay, that's good. What time are we at? Oh my God, it's only 8:20. It seems like 12 o'clock. Scan the board, make sure you're comfortable. we did a bunch of different types of things. Alkene, electrophilic addition reaction of an alkene through carbocation, Markovnikov rule, major product, minor product, stability of carbocation. There is a lot of things going on. Whole bunch of things are going on. Naming an alkyl halide. Remember, this is where the substitution reaction starts. This is the end of something and beginning of the SN1 and SN2 reactions. And then we looked at those molecules and we started getting distracted with enantiomers and chirality and things like that. So we covered a little bit of that here too. Okay, so I'm just trying to be as efficient as possible. Scan, make sure you're comfortable. You should be able to name these guys too. This is just propene, not 1 propene or 2 propene, because there can be only 1 propene. And cis trans doesn't apply here because this end of the double bond has 2 same groups, identical groups. Okay, let's go. All right. Let's use something that we almost saw, like what we were almost working with. Something very similar to that. Okay.
The board memory, Professor.
Board is off. Okay, it had to do it once. Okay. Okay, 2 reactions are happening with the same reagent on the arrow, OH minus. And on the left side of the arrow, you have 2 different types of compound. They're both alkyl halide. Let's name them one more time. So this is something you have already done. So 1 bromopropane. What's this guy? Name it. Name. Name, please.
2-bromopentene.
How many carbons?
Sorry, that's
No.
one more.
Please, you're making me nervous now. Every end, every band is a carbon.
Yes, I counted one more. Sorry, Miss Pentane. Sorry, butane.
Butane. So that's not how you name it, right? Find the longest chain and then find the branches and then you name it. So what's the longest chain here? Let me help you.
Propane.
The longest chain is a propane. And the groups are one of these groups and one of these groups. So how would you name the propane? Where are the bromine and the methyl group? And which one should be written first? So somebody help me.
2
2
dash bromo dash 2 methyl propane.
Please take note of that. Okay. Longest chain. Find the branches, name the branches, number the longest chain the proper way, and that's when you're done. Okay. Don't rush. Don't rush and make mistakes. All right. Let me ask you another question. What kind of alkyl halides are these? So these are all alkyl halides. This is an alkyl halide. This is also an alkyl halide. Methyl primary, secondary, tertiary. This one, is it primary, secondary, or tertiary?
Primary.
If you don't know what it is, we have covered it more than once in the past, so please watch the videos. Is this primary, secondary, or tertiary?
Tertiary.
Okay. An alkyl halide is reacting with OH minus. What is the role of an OH minus here? Is it a nucleophile or is it an electrophile? Does it have extra electron or does it need electron?
It's a nucleophile.
It's a nucleophile. So alkyl halide is reacting with a nucleophile. Alkyl halide is reacting with a nucleophile. So what kind of reactions are these if we are using the acronyms? Is it E1, E2 elimination, or is it SN1, SN2, or is it something else?
Would they be SN1, SN2?
SN1, SN2. Which one will be one step, the left one or the right one? Which one will be backside attack, kicking out the living group, boom, boom, done? Primary and tertiary. Primary alkyl halides like to go in one way. Tertiary alkyl halides like to go another way. Hi, Marley.
Is it the primary one?
Primary does what? SN2 or SN1? Does this guy like to make a carbocation or does this guy like to make a carbocation? Which carbocation is better? Primary carbocation or tertiary carbocation?
Tertiary.
So if tertiary carbocation is better, do you think this reaction will go through a carbocation or this reaction will go through a carbocation? Left or right?
Right.
Right. So if this is going through a carbocation, which one is going to be a two-step reaction, right or left?
Right.
Okay, I'm going to write down. So carbocation is going to happen here. Carbocation is not going to happen here. If carbocation happens here, this will be a two-step or one-step?
Two-step.
Two-step.
If this is not going to be a carbocation, then it's going to be one-step. If this is a one-step, how will the nucleophile attack? From both sides or only backside?
Backside.
Can I show?
It's fine. The little person can talk. It's add some breaks the monotony. So over here, don't be apologetic or be apprehensive. Nucleophile will attack from both sides. She's being exposed to organic chemistry early in her life. It's good for her. Okay, what else? Okay, so which one is SN2 and which one is SN1? Left is that, what is this? SN1 or SN2?
SN2.
What does one stand for? What is that one? One step? Or it stands for some other word? What does it mean?
Molecular.
Molecular. And 2 stands for?
Molecular.
Excellent. Okay, so this is going to be like this, and it's going to produce 1-propanol. And over here, if I write this, should you start screaming at me? Is that correct or that's not correct? Does SN1 happen that way, boom boom, or
No.
it just that happens first, right? So it produces a carbocation, bromine minus. Now OH minus comes from back or from front, and it produces this alcohol. Okay. Does the nucleophile, the better nucleophile, bad nucleophile, more nucleophile, less nucleophile, does nucleophile matter on the left, SN2, or on the right, SN1? Where does it make a difference? Left or right, SN2 or SN1?
SN2.
Very good. This could be a new movement. Nucleophile matters. Nucleophile does not matter. Sounds good. What else? Let's do something here. I just want to quickly talk about it. Okay. What kind of alkyl halide is this? Primary, secondary, tertiary? Vincent, don't answer.
Is it primary?
Okay. So if it is undergoing an SN1 reaction, SN2 reaction, it's going to be undergoing an SN2 reaction, right? Boom, boom. And it'll form. Did I put too many carbons? No. Okay, butanol. 1 butanol. Sometimes, so if I label the carbons, there is a way using Greek alphabets we can label them, right? So carbon 1, 2, 3, and 4, they can be labeled as the Greek alphabet. So what do we call the carbon 1, the first carbon from the living group? What is that called? The Greek letters, remember? Alpha, beta, gamma, delta. What's the first carbon called?
Alpha.
Next is beta. The beta hydrogens are important. We talked about it. We didn't spend a lot of time, but we talked about it. When it's attacking a carbon, It's behaving like a nucleophile. Sometimes the nucleophile doesn't work hard and acts lazy, and instead of doing the right thing, it does the wrong thing, okay? And it acts like a base. So when it's acting like a base, it does something different. What does it do? It's a different arrow. It plucks protons or proton. Which proton does it pluck? Alpha hydrogen, beta hydrogen, gamma hydrogen, delta hydrogen. Does it ring a bell? You better study. It picks up the beta hydrogen. The beta hydrogen, beta carbon bond breaks, falls between here, and this guy goes away, and it's a completely different product. It produces an alkene, butene. This is 1-bromo-butane. This is 1-butanol. And this is 1-butene. What is this reaction called? The second reaction, the funny reaction where the nucleophile did not act like a nucleophile, it acted like a base because it plucked a proton.
Elimination reaction?
Elimination. Sounds good. Is it glaring too much?
Also, he could kill.
Did someone say something to me, or you guys are okay with what we have covered? Primary, secondary, tertiary alkyl halides. You better figure out how to distinguish between them. Primary, secondary, tertiary carbocations. You better figure out how to do that. Tertiary carbocations are most stable. Primaries are horrible. So primary alkyl halides do SN2. Tertiaries do SN1. Okay.
Professor?
Yeah.
Could you describe which reactions happen faster depending on what is used in, like bromine or?
Okay. So yeah, sure. So if you have a bromine, okay, if you have this guy versus this guy. So let's say we have fluorine. They're both undergoing the same reaction. OH minus, and it's producing the same compound from top and bottom. Okay, this guy and this guy. Which one will be running faster? The bromo compound or the fluoro compound? How do we use our logic there? Anybody wants to articulate?
The bromo compound would be faster because it's more likely to survive on its own.
Perfect, Jana. You are thinking right, but if I ask you to say more like a professional manner, like if you're giving a presentation, how do you say that bromine is better something than fluorine?
It's more stable.
It's a better leaving group.
There you go. That's what I was looking for. Better living group. Yep, that's it. Thank you. So this is going to be a faster reaction. Perfect. Very good. Thanks for asking. I appreciate that. I'm really enjoying this review, unlike the previous review. I think I did it before the first exam, and I think 3 or 4 people showed up, and nobody wanted to participate. Okay, so let's talk about some aromatic compound and then some carbonyl chemistry, and that's going to be it. Where are we with time? Oh my God, 8:40. Okay, no, that's fine. We have time. Okay. Again, this is not it. Okay, this is just a glimpse of looking at the whole river. Okay, there are more things going on. Pebbles, fish, octopus, crabs, whales. Okay, everything is there. So you need to take a holistic approach. Make sure that you're not missing something. Just don't bank on the review and come to the final. Please study a little bit more than that. Okay, if you have forgotten a lot of things. And don't watch the videos while driving, please. Don't do anything really foolish and get into trouble. Okay, so let's see. All right, so I'm going to draw a bunch of compounds and ask you aromatic or not. That all right. Aromatic, yes or no?
No.
Why not? Just give me one good reason.
Not cyclic.
Sorry?
Not cyclic.
Not cyclic. Aromatic? It's like you have gone to Walmart with your son or daughter or nephew or niece to buy shampoo, and this little guy doesn't know what shampoo is and looks at everything and says, "Is this shampoo? Is this aromatic shampoo?"
It's not cyclic either. So no.
Not cyclic. This is cyclic. Must be aromatic. Let's sniff it. Doesn't smell good. Aromatic or not? What's the problem? Or what's the good news?
The double bonds are not alternating.
Double bonds are not alternating. Sounds good. So not. How about that triangle with a double bond? Yes or no? Somebody else. Not Swal.
Isn't that the one where there's like exception to the rule for the triangle?
Don't think about exceptions. This is all sigma bond. Sigma, sigma, sigma hydrogen, carbon, hydrogen, sigma, carbon, hydrogen bond. I came up with a description. Remember, I call it something wall, and I say that that's a bad thing. It cannot be aromatic. What is that
A
word?
sigma wall.
The sigma wall. So you've got the sigma wall problem. Okay, not aromatic. We'll get to that. I think what you're thinking, Jana, is this guy. We'll get to that in a second. What about, let's go to the simple benzene. What about this molecule? Aromatic or not? Hexagon,
Yeah.
why? Let's go through the rules. Rule number 1. What's rule number 1?
Cyclic.
Cyclic. Rule number 2.
Alternating double bonds.
Alternating double bonds. The last rule. What am I trying to hint? How many pi electrons or labile electrons it has to have? How do you have to write it? What's the formula?
2n plus 2?
No.
No.
Or
Not
n plus 2.
4n plus 2. What's the value of n can be? Can it be half, 3/4, 5/6?
Whole number.
Whole number. Can it be 0?
Yes.
Yeah.
So this is 6. Okay. For 6, what's the value of n? N equal to 1. Okay. So this dude is aromatic. It smells. Comes with a fragrance. What about that? Cyclic. Alternating double bond, there is a problem, but it's not a terrible problem. It doesn't have a sigma wall, it has an anion, a carbanion. And I think one of the exception to the rule, I think Jana will probably make sense to you. You can have a positive charge, you can have negative charge, or you can have something with lone pair or lone pairs. Okay, that can suffice. This dude has a negative charge. So how do you now count the electrons? 1, 2, 3, 4. What do you do with the negative charge? Do you count the electrons?
Yes, you count the lone pair.
You count the electrons. So what's the number here? 6. If it is 6, aromatic. What about that molecule with a weird oxygen sitting there like a water molecule? Cyclic. Alternating double bond, there is a little problem, but it's got something, the problem place has lone pairs. So what do you do? 1, 2, 3, 4. What do you do with the 2 lone pairs? What's the guiding principle?
You just
You're gonna
count one of
one
them.
lone pair.
So 6, yes, very good. Jana will be happy. Cyclic. Double bond in little sketchy area. So you count 1, 2, and nothing. 2. Aromatic or not?
Yes.
Yes. The value of n equal to 0. This is the smallest aromatic molecule. And I was very proud to say that my brother worked with the professor who actually first made it. Ronald Breslow. Aromatic chemistry, we talked about some nomenclature, simple nomenclature. Let's do 1 or 2 maybe. Name it. Let me see if you can do it now. Can you name the aromatic molecule?
I'll give it a try. Is it 1-bromo-3-isopropylbenzene?
What do you guys think? One bromo 3 isopropyl benzene seems is the answer from SWOD. What do you guys think? Agree, disagree?
Shouldn't there be a cyclo?
Vincent, what did you have for breakfast? Cyclo? Cyclo what? What's the main molecule here?
Benzene.
Benzene. So that's the main trunk of the molecule. That's benzene. So you're decorating benzene. This is one group. This is one group. So it's going to be something benzene, like something cyclohexane, like something hexane. It's going to be something benzene. This is the main group. This is the main disk, and you're sticking things there. Okay. One group is called bromo, starts with B. One group is called isopropyl, starts with I. Since you're putting bromo first, according to alphabetical order, you start numbering from there. You don't go the long way. If I were taking the path in the real life driving scenario, I would definitely take the long way by mistake. Okay, 1 bromo, 3 isopropyl benzene, perfect. Good job. Okay. I'm going to just show you the chemistry of these molecules. Let's do it here. Okay. Benzene reacts with bromine and iron tribromide as a catalyst. What's the product? What happens? What do you get out of this reaction?
With the bromo?
With the bromo group somewhere, right? Bromobenzene. When benzene reacts with sulfuric acid, you get a product out of it. Anybody remembers? You can look in your notes or wherever. When benzene reacts with sulfuric acid, concentrated sulfuric acid, very concentrated, what product do you get out? SO3H. When benzene reacts with nitric acid and a little bit of strong acid catalyst, what do you get out?
NO2.
Sorry?
NO2.
Nitro group, NO2. When benzene reacts with, let's say, an alkyl halide, chloroethane, and aluminum trichloride as a catalyst, you get something out. You decorate the benzene ring with something very interesting. This piece. You get ethyl benzene. Whatever is the alkyl group that gets attached to the benzene ring. This is the chemistry of benzene. Okay, 4 reactions, we talked about it. These reactions are called electrophilic, aromatic,
Substitution reaction.
substitution. Because you're substituting one hydrogen with something else. Okay, in this case, the electrophile is bromine plus. In this case, the electrophile is this whole thing, whatever this thing is. In this case, the electrophile is NO2. In this case, the electrophile is CH3CH2 plus. Electrophilic aromatic substitution. Okay. Scan the board. Make sure that you guys can handle these questions on your final. Okay. 4 reactions we discussed: bromination, sulfonylation, nitration, and alkylation. Okay, they all fall under the same category. All right, let's talk about the final step, which is carbonyl chemistry. Check the syllabus for the final exam schedule, because it's not at the regular time, because I was asked some questions about when is the final. Check the syllabus. Okay. I'll verify the final time, and if there is any, if I made a mistake, then I'll correct it. Otherwise, it's what it says.
Sorry, it says December 15th at 1:15.
Yeah, for what? Yeah, which class are you in? I forgot.
What class am I in? Monday, no, Tuesday, Thursdays.
You're Tuesday, Thursday. Okay, yeah. One is December 15th, the other one is on a different day.
Mine says December 16th, and it starts at 8:45 to 10:45.
That's what it is, probably. Yeah, thank you. Just make sure that you are available during that time. Just make sure that you don't have any oops moment. If you miss the final, you are in trouble. There is nothing I can do about it. Okay. You can come up with some excuse to your employer. You can make up some story. I'm not giving you bad ideas, but then taking the final is very important if you care about this course. Okay. You can say my chicken flew away, went for an international flight. I don't know if your employer will believe you. You can say my instructor asked me to say that to you. Okay, so carbonyl chemistry. Let's see if you can identify some of these compounds. Okay. I'm going to point at different molecules. I need you to tell me what they are. What kind of compound are those? What is number 4? The list is aldehyde, ketone, acid halide, anhydride, carboxylic acid, ester, and amide. So 6, 7 compounds. What is this?
Carbon.
You can just use the second word. The A word.
It's an acid.
An acid. What about 2? Somebody else. Take a shot. You can look in your notes, or I don't know if you can watch your videos right now while you're answering. I don't know how many devices you have. What is it? Carbonyl and a halogen on the side.
Acid halide.
Acid halide. Number 1. Carbonyl with 2 carbons on the 2 sides. What is
Ketone.
it? Sorry?
A ketone.
Thank you. Number 3. Two molecules of acid, remove a molecule of water, you get this.
Anhydride.
Anhydride. What about 5? Kind of like an acid, but not really. Instead of the hydrogen, you have an alkyl group on the oxygen. I drew it backwards. They smell good. They're everywhere in the nature. It's an E word.
Ester.
Thank you. Number 6.
Is that an amide?
Yep. You spotted an amide. Good eyes. What did we not write? Which functional group under carbonyl I haven't showed?
Did we not do carboxylic acid? Oh, we did. Okay.
Aldehydes.
What's the formula of the smallest aldehyde? How many carbons, how many hydrogens, how many oxygens? Say that again. I can't hear. How many carbons?
2.
2 carbons, wrong answer. Smallest aldehyde. How many carbons, how many hydrogens, how many oxygens?
Is it Ch2O2?
Wrong answer. Almost there.
Is it 3 carbon?
No. Think about a carbonyl. Imagine that molecule. Make a mental image. Carbonyl, and all you need is what needs to be there to make it an aldehyde. To the right side and left side can be something very small.
That's CH2O.
Yep. This is an aldehyde. On the other side, put a hydrogen. Formaldehyde. You know the smell if you have been in a hospital or some medical facility. All right, two of these compounds, okay, these are the carbonyl compounds, okay? This is something that we have learned the last, so maybe you can watch the videos. I'm not going to spend a lot of time here. They react with what? When we describe the reactions for these carbonyl compounds, we start with their three-word description, right? Something, 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 okay? What's the first word? What do they react with usually? Electrophile or nucleophile? Louder, please, I can't hear you. Nucleophile. So these reactions are usually nucleophilic. What's the second word? Carbonyl or the different word that pretty much means carbonyl?
Acyl.
Nucleophilic, acyl. What's the last word? Is it the same word for all 7 compounds, or is it different for some and something else for the others?
It could be substitution or it could be addition.
Okay, very good. Substitution or addition. Okay, let's call it 7, aldehyde. Which 2 compounds do addition?
Ketones and aldehydes.
What shortage do they have that they must do addition? They cannot do substitution. What's the problem?
They don't
have a leaving group.
So these guys, this one, this one, this one, this one, and this one, they do substitution. Okay, because they have what?
a leaving group.
Which living group is best? Which compound has the best living group? 2, 3, 4, 5, or 6?
2.
Who is next?
3.
Who is worst?
6.
Yep. Excellent. Let's practice maybe one or two chemistry. I really don't have a lot more energy left right now. Make sure you follow the chemistry that we covered. Okay. If you take an aldehyde or a ketone, in this case we took a ketone, and if we react it with water and H+, what do we get out? What does that molecule look like? Can you help me? Can you help me draw it? This is important. This is something that we studied at the very end, the last few classes. Aldehyde or ketone, water with an acid catalyst. It produces something, a very symmetric molecule on the top.
OH?
How many, 1 or 2?
2.
What is this guy called?
Gem dial.
Thank you. Okay, sounds good. Let's practice one more. Let's take an aldehyde, okay, and react it with an amine. Methylamine. Help me draw the product. What happens when an aldehyde or ketone reacts with an amine? Primary amine, it's very important, a primary amine. NH2. There must be 2 hydrogens. How do you draw the product? I draw the main frame. I start drawing the double bond. I don't complete the carbonyl. Then what do? What do I put instead of the oxygen? Who is coming in? N. Then what do? Do I draw it straight or do I draw it slanted to the left or right? If the nitrogen is sitting in a double bond, what's the bond angle? Is it 180 or 120? Use your preceding knowledge. It's 120, so the molecule will be bent to the right or to the left. And what should be attached to that methyl, to the nitrogen? Whatever alkyl group it's attached to, it's this guy. Okay, so it's going to form something like this. There is a name for it. It almost sounds like an amine, but starts with a different letter.
Amine.
Imine. Some people call it imine. That just sounds weird. Okay, that's called an imine. Sounds good. There are a few more reactions under aldehydes and ketones. Please study that. We can't cover everything in a review. Okay. Let's do a few more reactions for those guys. I'm going to erase the board. Maybe you can just scan the board maybe for a minute or so. Then I'm going to show you some chemistry of the 5 molecules, and then that'll pretty much be it. Who is calling me? Must be a scam.
Hello?
Scammer. Dentist wants to take money from me. All right, so what I'm going to do is I'm going to erase the aldehyde, ketone, and everything else. I'll just keep just the molecules up here, okay? The 5 molecules. You know what? Let's just erase everything. Let's start with a fresh, clean board.
Blurry.
Blurry? Is the board blurry? Is that what you're saying? Yeah. Okay. What is it blurry again? No. Okay. What is it? Acid what? Acid halide, right? Is it going to be undergoing nucleophilic acyl addition or substitution? Are you guys running out of energy? Nucleophilic acyl addition or nucleophilic acyl substitution?
Addition?
Does it have a good living group or not? Is this a good decent living group or a terrible living group or not at all a living group? Or you guys just ran out of energy all of a sudden? Like no more charge? You need to charge? It's called what? Acyl, it's an acid what? What is bromine? Please, somebody step in and assist.
It's a substitution reaction because it's a
Good.
acid halide.
Acid halide. Thank you. Appreciate it. That's Catherine. No, that's Angelina. Okay. Thank you, Angelina. Okay. So yeah, it's going to be substitution. So that's an acid halide, and I'm going to draw over here. Let's use color coding. Red is leaving group, blue is nucleophile, or purple is nucleophile. Okay. So I might draw something like this. I might ask you first, what is it? You know, I give you 4 choices. You say it's an acid halide. Okay. Okay, done with that. You know, my style, right? I'll have a question, then I'll have a bunch of follow-up questions. Then I might say, what is this? I give you 4 or 5 choices. You know, acid halide, acid esters, anhydride, and amide. What is this guy? Almost done with the review. Just hanging there for a few more minutes. Somebody. Find some energy. Just go for another 10 minutes or 5 minutes. What is this? Carbonyl, oxygen, not hydrogen, but an alkyl group. They are called the E word.
Ester.
This should be at the tip of your tongue. I mean, you should be really well versed with it by the time you show up on whichever day for your final exam. Not show up, I mean you're there, right? Okay. Is it possible? Is this a legitimate transformation? Can you go from an acid halide to an ester? Yes or no? Is it downhill or uphill?
Downhill.
Downhill. That means it's a possible transformation, yes or no?
Yes.
Okay. If it is a possible transformation, this is the living group that gets out, and this is the incoming nucleophile. What shall I write here in the box as a nucleophile that can make this transformation possible? What piece, Lego piece, you need to bring in to replace the red with the purple? What kind of molecule should be there? You can help me write, like you know, Shantanu, you write this and then attach out this and then extend it with this. Can you help me? What goes in here? Purple replaces red. That's it. It's not like rocket science. Rocket science is pretty complicated. I'm just beginning to learn that. There is a reason for that to be a proverb. It's not rocket science, Joe. What goes in that box on the arrow? What do you need to use to hit this guy with so that you end up making an ester? What's the nucleophile? This is your nucleophile. What does the nucleophile look like? Something with a lone pair. It doesn't have to be a super duper, like a negatively charged species. It can be a neutral species. Anybody? Some of you guys are just cameras off and you're just not even participating. That's not what you signed up for. I know that some of you are trying to answer. I appreciate that, but others are not even trying. I will make sure that I don't ask this.
Somebody posted OH in the chat.
I'm not looking at the chat. So if you write in the chat, it doesn't
I'm just
help.
letting you know that's what somebody
I'm
posted.
standing here, right? So I cannot read the chat. That's a bad way of communication. If you know your friend doesn't have a cell phone and if you text him, you can't communicate. I'm not looking at the chat. I'm standing here. I don't have a telescope in front of me. So you don't have to read somebody else's chat. Somebody needs to turn on the microphone or the camera and talk to me. That's how.
And I've been participating even though my camera has been off. Thank you very much.
That's fine. So yeah, just speak up. Answer your question. What answer you have. Appreciate that. Yeah. You don't have to turn on your camera, but you can speak. What goes on in that box? Remember I did this the other day? That's the living group. And from here, you are essentially making that. So this is getting out. Living group is out with a negative charge. So what needs to come in? What piece do you need to replace the red piece with? And that's the purple piece that's written here. Not piece, not like a cartoon shape, but it's a real molecule. You should be able to answer that at the end of Chem 8 at this stage. Somebody should be able to. Anybody wants to assist? Rescue the review? No idea? We have discussed it in the class. Maybe you should go back. This should be your homework. Go back, watch the video, and figure out what needs to be happening there, because it's very important. Okay, you have acid halide, you have anhydride, there is carboxylic acid, ester, and amide. Okay, it is possible to go from here to here. It is possible to go from here to here. It is possible to go from here to here. It is possible to go from here to here. It is possible to go from here to here. It is possible to go from here to here. It is possible to go from here to here. It is possible to go from here to here. It is not possible. It is not possible to go from an acid to an amide. We discussed it in the last video. I'm going to upload that video for the Tuesday, Thursday class as well. That's not possible. Okay? Going downhill is possible. When you go from here to here, you use this piece, this entire piece. When you go from there to there, you use this piece as a nucleophile. When you go from here to the ester, you use this entire piece as a nucleophile. That's your nucleophile. Okay? So over here, you just trace from what you see on the right side. You can make it negatively charged, or you can make it like just a neutral compound. You just stir this guy, react this guy with ethanol, and you have your product. That's it. We also talked about, I'm not supposed to be lecturing, but then it seems like it's inevitable because you guys are not answering or having trouble, so that I understand. This is the last thing, so maybe you haven't had the chance to review it, so that's totally fine. Acid halide to anhydride, it's possible. You use this piece. Acid halide to an acid, it's possible. You react it with the water. Acid halide to an ester, it's possible. You just use that alcohol on that side. Whatever's alkyl group, oxygen, and you add a hydrogen. That's your reagent. Acid halide to an amide, it is possible. You just use whatever on this side and add a hydrogen where the bond is. Okay, NH. In this case, it's going to be NH3. It is possible to do the same reactions downhill from here. It is not possible to go uphill unless you're using some special reagents. So it is possible. It is possible. It is possible to go from I showed you like a couple of reagents to go uphill, starting from an acid. How do you go uphill from acid to an acid halide? A special reagent, thionyl chloride and heat. You need to memorize it. You might see it on the final. Going uphill from here to here, anhydride. What do you use? Phosphorus pentoxide, a dehydrating agent, and heat. Okay? So that kind of summarizes. So you need to be able to figure it out. Let's do one more example because you guys had so much trouble with this transformation. Let's do one more. Okay. So you just bring in the nucleophile. So it's you are replacing the red with the purple. So you bring in the purple here. So that's all you need to do. Maybe my language, maybe I have some problem with how I describe. Maybe I'm not speaking your language. I don't know what the problem is. You basically replace this piece goes out and that piece comes in. It's like playing some sort of Lego type of game. You basically have this, right? That's the living group. Think about it this way, okay? Alkyl, carbonyl, living group, and your product has the nucleophile on the other side. This is alkyl halide. Let's make it green. I mean the proper red. Okay. Let's say that's the carbonyl, purple, not purple, whatever color this is. Let's say something like pink. That's your living group. Okay. Over here, all you have is this, right? So it's a substitution reaction. All you're doing is you're going from an acid halide halogen to an ester. In the ester, you have the purple oxygen and a ethyl group. So what do you react? What do you react this guy with to bring in this group? You bring in this group. That's your reagent. You can use this guy as a negatively charged species, or you can bring in this guy as a neutral compound by adding a hydrogen. That's all. So when you're going from this to this is your reagent. Okay, same deal here. When you're going from here to here, Let's say this is the brown piece. You bring in the brown piece here, okay, this whole thing. That replaces the red living group. When you go from here to here, you bring in this guy, OH minus or water as a neutral compound to replace that with this. Okay, when you go from here to the amide, you bring in the amine with a hydrogen, extra hydrogen, so NH3 to replace the halogen with. That's all. It's substitution. You're substituting the living group with bunch of different things. It's like a star reaction. You replace it with one thing, you get an anhydride. You replace it with water, you get a carboxylic acid. You replace it with an alcohol, you get an ester. You replace it with an amine, you get an amide. It's that's it. So try to follow the logic, please. Please, 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 because it's important for the final. Okay, you're almost done. So try to see the logic here. If you get the logic, it's going to be much easier for you to pull it off in the final. Let's do one more example. I really want to do that. Let's do one more example, and that will pretty much be it. Okay, so let's use this starting compound, okay, anhydride, to something else. Let's see if we can do it. Let's start with an anhydride. This is an anhydride. What is its living group? Well, it's a carbonyl compound. Why is it a carbonyl compound? Well, let's consider one carbonyl. It's got a methyl group on the left side, so that's your left side of the carbonyl. The right side of the carbonyl is supposed to be a good living group or a bad living group. That's your living group. You want to make from here, you want to go downhill all the way to the bottom. And you want to make this molecule from here. Carbonyl is left. You want to make an amide. So this is an anhydride. From the anhydride, you want to make an amide. How do you do it? Is it number one? The question number one is it a legitimate transformation? Are we going downhill or are we going uphill? We are going downhill, so it's probably doable. Now, is there something tricky about it? Doesn't look like it. We are not making acid to an amide. That's the tricky part. That's the only sketchy reaction that doesn't happen. I explained why it doesn't happen. Because the amine does not react with the carbon on the carbonyl, it plucks a proton. Then it's all screwed up. That doesn't have that sort of problem. This is a legitimate reaction. So again, this is the living group. This entire thing is the living group. Let me just change the color. You are replacing the red with green. So you just bring in the green guy to replace the red guy with. Substitution, nucleophilic acyl substitution. So you draw the green thing here. Start from the right side. Nitrogen, methyl, methyl. Do you want to put a negative charge? I told you that's an overkill. Don't do that. Just make it a good amine. Just convert it into an amine. So what do you do when you want, it has to be an amine? A nitrogen is attached to three things. So that's going to be a hydrogen, and it's going to have a lone pair. That will enable this guy to act like a nucleophile. This is your nucleophile. This is a legitimate nucleophile. You don't want to do this. This is definitely a significantly more powerful. This is an overkill. Don't do it. I already warned you not to do it. This is an overkill. It will probably do more bad than good. So just use a normal, legitimate nucleophile. You build it from this side of the product. So you look at the product and you figure out what you need to react with. You just do the process of elimination. It's not that difficult, right? So carbonyl is there. The alkyl group is there. Okay, carbonyl and alkyl, and carbonyl is there. All you're doing is you're going from an acid anhydride. This is the whole anhydride, OCO, whatever. You're replacing it with the nitrogen thing. So all you have to do on the arrow, you have to bring in the nitrogen thing, nitrogen arm to replace it with. Okay, that's all you're doing. So that's the reagent. Is it making sense? Am I making some sense? I didn't mean to lecture, but I ended up lecturing. Okay, I'm going to sit down. I think we are kind of done, unless there is somebody has any question. Hi, Brian, Aaron, Allison, Angelina, Damien, Chengshi, Guillermo, Vincent, Cassidy. You're still surviving. So, Diamond, Tetesia, Monique, and Marley. Thank you for attending the review.
Are you going to give us extra credit for attending the 7 a.m. review?
No. There will be something. I was actually thinking about that. Since it's being recorded, I am going to mention it. I do not know, actually, I haven't gone to Canvas yet. If I see, what's the percentage I should pick? If I see more than 90% response to the, what is that called? Course something? Course, what is it called, Cassidy? Course rating, right? If I see more than 90% done, so 45 students, so maybe over 40, then I'll add 1 point to the total of everyone. I'm going to send an announcement too. Yeah, otherwise you guys are not going to do it, because we were having a discussion about it last night over dinner, and our son said, he's a undergraduate student in a different school. He said, oh, you have to show the carrot. I said, he's generally a pretty decent guy. He's not like obnoxious like me. And he said, well, you need to show them a carrot. I said, what do you mean? He goes, well, tell them that you're going to add a 1 point. So this was our son's idea. So blame it on him if you think I'm tricking you. So if you guys do the course rating, and if I see like more than 40 of you guys have done that, and I'm going to add, what are you doing, Cassidy? Are you trying to send some energy through the computer to me? Like you're trying to disable me or something?
No, I'm just taking pictures of my notes.
No, I'm just kidding. Okay. Yeah, it's being recorded, and I'll share the recording too. So if I see more than 40 responses for the course rating, then I'll add 1 point. Okay. I'll send an announcement too. Any other questions? Thank you for coming on a Friday. You can go back to sleep now. I need some more coffee. This McDonald's coffee was horrible. I'm very picky about coffee. I think I buy the most expensive coffee from Costco, which is not that expensive, like Pete's Coffee. No problem. Thank you, Guillermo. I appreciate that. You're using the. I can see the chat now. Whoa, lots of chatting going on today. Ho, not O. Okay, HO, not OH. Okay, sorry, I'm just messing with you guys. Purple group with an OH. It looks correct. Okay, now I can finally see. Sorry, late. Yeah, no problem. No problem for a bit delayed. Mostly just me. What does that mean? I'm teaching Chem8 again in the spring. Not spring. What semester is this? This is fall, right? Yeah, spring. So maybe you should not recommend me to your friends after what you have gone through with me. The torture. All right. So what do you looks like? It looks like you're in a bird cage playing chess. Okay, we are officially done. Study, please. Do well. If you ace the final, you will be rewarded. I promise. Okay. Bye, guys. Have a good weekend. And you can always email me if you have any burning questions. Take care. Bye, Brian. Bye, Sword. Bye, Chengshi. Bye, everybody. Bye, Diamond. Take care.